Greetings, everyone. Today's presentation is about building the future applications using the microservices architecture and the upcoming edge computing and the quantum computing. How to develop applications with the cloud innovation at scale, and how it is transforming the JavaScript development through all these cloud native patterns and distributed architectures. With this coming to me, I am Surya Prabha Busi. I'm a graduate from Jawaharlal Technology University in Electronics and Communication Engineering. And I come with around 18 plus years of experience developing cloud native applications. And today I'm going to explain how we are exploring the intersection of JavaScript ecosystem and modern cloud native architectures to develop highly scalable digital platforms. So, all through these years, I've been working with many cloud native applications and seeing how they are evolving and playing a major role in today's development. And going to the next slide. As we all know, all through these years, JavaScript has been one of the major front-end frameworks, and how it's been playing a key role in many web applications development. Today, we are going to see how it has evolved now with the backbone of cloud native applications. And with the global development and everything being global, anything being global these days, it is highly important to keep in mind the development of the application to be highly scalable, reliable, and easy to maintain. And so now the JavaScript developers are now being architecting using these microservices and edge computing for solutions to have the real-time responses and the distributions that can power how the applications and the digital platforms can be highly scalable. The transformation today needs highly how we build is highly impacting how we build and deploy and manage applications at scale. With this, I'll try to go to this agenda of the meeting, which looks like this. Today's session roadmap will start with the microservices transformation, how its adoption has a big surge, and what are the architectural challenges being faced by the development teams. And then we'll be moving on to the edge computing and how it is impacting with a huge latency reduction and the real time processing of data. And then we'll move on to the multi cloud strategies, how the flexibility versus complexity trade offs play a key role in designing and architecting today's applications. And also, we'll look into the serverless, the future technologies like the serverless and the quantum computing, which are the upcoming next generation architectures. With the technology in its boom, it comes with the challenges of security as well. So towards the end, we'll also discuss how the security also being evolving with the new models of the zero trust and how it's being a major part in the threat detection. With this, I'll go into the presentation, which starts with we'll see how the microservices architecture has been evolved with some numbers. But before that, as we understand, for years we have been stuck with monolithic architecture where everything is being developed and deployed as a single unit, which includes all the front end, back end services, and business logic. Everything as a single unit being deployed and as an executable unit, which makes it easy for development and deployment. But as the complexity of the application grows, we have been facing challenges of updating and maintaining the application, and even to update to the newer technologies. It's being a great challenge. With that came the microservices architecture as a solution, where it's the collection of individual independent services, each having its own business logic, making it easier to develop and deploy and easy to update, maintain, scalable. What all the newly trending features of a global application is required is satisfied by this microservices architecture. And as we see, the adoption surge from 2019, which was at 45%, now to till date, it's been surged to 91% as of 2024. So it has basically changed even how we architect the JavaScript applications, enabling high scalability and maintainability and easy to operate. Sorry. With that, I would like to go to the next slide. So let's see how these microservices performance impacts the applications. These are some numbers with some case studies. We see that there is a 76% deployment time reduction as we understand the microservices come as a small units and with its own business logic is where we can scale the particular business unit which we are expecting more traffic, so it's easier to deploy, develop and maintain. So that's what helped to see this 76% time reduction in the deployment and through the automation strategies. And if we see the cost savings, obviously with the monolithic architecture, with the high amount of infrastructure involved, we need to be able to maintain the infrastructure as well. But with the newer technologies of cloud, obviously the maintenance is less and the infrastructure to be maintained comes down, which brings the 50% operational cost savings with all these newer optimized containers freely available in the market. High volume of cloud native providers are available. We'll go into the details of that in going forward, but now and so we have seen this huge impact in sense of the positive way, but coming to the challenges the teams having today with this microservice architecture is the clear line of division between the services of decomposition of the business logic into the service units is highly important to design to have this highly effective microservice architecture designed applications. So that's what we see the challenge currently the teams have been facing, which has been 67% observed. As we go forward with that, that's pretty much about the microservices architecture, how it has evolved, what it means, and what are the impacts in numbers. The another major trending technology is the edge computing. It brings the computation closer to the data sources, having these JavaScript applications, having the real time processing easily available and quickly available, where the quality and quantity of data is highly critical. For example, in the healthcare domains or be it be manufacturing, where the sensitivity and the quality of data is critical. And basically, the edge computing provides a high latency reduction as the computation is done closer to the data sources. With this, JavaScript developers now have to keep in mind while designing to have the edge computing available while designing and have it right from the start of the application design and makes it the applications more effective and delivering a great user experiences. We talked about the edge computing. Let's move on to the next. So here are some edge computing performance gains that has been all observed through these years. With this process improvements, we see a 45% faster processing times, 42% better real-time data handling, and as we talked earlier, examples, there is a 33% efficiency boost in healthcare. Well, obviously, with the right data available in so fast, it's quick to take decisions and improve the efficiency in the healthcare provided. And also, we have seen 56% faster emergency response in the manufacturing section, where there is huge dependency between different departments, where they have to go hand in hand, and the data being available real time between these departments has shown a significant increase in the efficiency. Now let's talking about now that we have seen how the microservice architecture has been playing and the upcoming edge computing. We will talk about the multi-cloud strategy and its complexity involved. Now, as we all know, with this traditional monolithic, it the maintenance of the infrastructure being of hugely complex and also being cost involved. The cloud technology where it's being available in marketplace from different providers, it's being a huge impact of this multi-cloud in designing the applications and deployment, which involves great benefits as we see the integration challenges. It was initially when during the adoption phase we saw this 52% hurdles where it is hard to decide between the hybrid public cloud, private cloud, choosing between them and get your right cloud strategy for your application. There were some initial challenges, but which through time has improved a lot. And as we understand, with the infrastructure being maintained by providers, most of it, with the new deployment strategies like the SaaS, PaaS, and infrastructure as a service, the governance benefits has hugely reduced, and structured cloud governance could lead up to 41% reduction and helping the applications and the teams to easily maintain their applications. And also we understand the cost optimization as we discussed it. There's been a significant decrease of 32% now with moving out from our monolithic native infrastructure to the cloud architectures. As we understand the multi-cloud being available in market, we move on to the next slide, which where we are discussing about to discuss how the cloud architecture is available, what are the different types today available. As we understand, there are like the public clouds, which where you can share your cloud space with other people and other organizations. Which comes with much lesser cost as you share your cloud with others, and there's a private cloud available which is specific to you and which is a little expensive but comes with the safety and all the cloud space available for your organization. And there's also a hybrid cloud architecture, which is a mix of this both public and private. And the right decision and the right strategy of this cloud architecture is very important in designing the today's JavaScript applications. As we see, the success requires careful orchestration between public, private, and edge computing resources. How critical is the data to be processed, and do we really need the edge computing? And is it effective to our application? These are the key points to be taken into consideration while designing the applications. And the right cloud architecture proves seems to be the mantra of success these days. With that, we'll see how this serverless revolution has come up. As we see these days, with the everything is available as a service, be it be platform, be it be infrastructure, and it be anything. There comes the functions as a service. These serverless architectures have really transformed the JavaScript development, the workflows by reducing the complexity, as we all understand, by improving the scalability. The 33% we see 33% reduction in the developmental cycles, obviously with the less amount of infrastructure worries and quick CI/CD available. There's a huge reduction in the development cycles, leading to the faster time to market for its JavaScript applications. These benefits include the automatic scaling, the resource management, as this, and also the cost savings with the paper execution model. If you are not using, there's no need to pay. So that's paper execution cost model is showing up significant cost reductions. And with the new CI/CD technologies available like the tech or be it be Jenkins, the significantly reducing the deployment times makes it easier for the business to concentrate on their business and grow to be highly scalable and highly effective applications. That's how the serverless revolution plays a key role. That let me talk on the next topic, which is the quantum computing. As we understand, it's closely related to the quantum mechanics, wherein huge chunks of data is processed at a lightning speed, which speeds up by the 25 times in the complex data processing. So this resulted in a great optimization, and also the JavaScript libraries being able to integrate this quantum inspired algorithms. It's still under research. Would say this is the future, the quantum computing going to be our future. This is good to know as of now, but significant results have been proven till date, but it's still under research. So that's what we are seeing here about the quantum computing, which highly results in the speeding up of the data processing at a lightning speed. After that, I would like to, as we said earlier, as the technology is being in great boom, there comes the issues with the security as well, which leads us to this zero trust security evolution, where the least privilege is being provided to the users, and the security being very tight, not allowing everyone to have every access to everything. The access would be provided on the need basis, which highly reduces the threats, and having access to malicious activities would highly be reduced. And we see a 37 improvement with this threat reduction and mitigating the security threats with this zero trust. And as I said, this identity verification provides access to where and when needed only to the specific people, and least privilege is being maintained all through the application development. And this involves the continuous authentication and authorization for every service integration. So we talked about the microservices architecture and how the edge computing playing a key role, and there comes the serverless architecture and the quantum mechanics, and how we can highly secure this with the recent zero trust security evolution. We'll move on to the next slide. So that's great. Everything looks good, but obviously everything comes with challenges as well. Now we are trying to see the actionable insights, how JavaScript engineers have to keep in mind and effectively use all these technologies to design and develop their applications. So the very first point is coming to the microservice architecture, where we understand it is the collection of individual services. Excuse me. Individual services having their own business logic. There comes the challenge of the service decomposition. Right understanding of the business is key in designing these services, which is being initially was a challenge where with this decomposition and having a right business knowledge. But moving forward, it has greatly improved, and we are seeing effective results with the microservice architecture. Also, the key component, as we discussed, the highly available and reliable data is key in critical industries like the healthcare and the manufacturing. Where the edge computing has to be put into place in the first thing to be put in place while developing the JavaScript applications right from the start. Then we also understand that the multi-cloud governance, it should be effective to decide to reap the right benefits of having the right cloud strategy designed to decide what you need. Is it be public or the cloud or the hybrid? Having the right knowledge was really important to design the cloud strategy required, and providing a great governance for reliability benefits, cost and reliability benefits. There comes also the security, which we discussed, which involves the integrate the zero trust principles while building the security into every layer of your JavaScript, and provide least privilege policy so that it's tightly secured and highly effective with the security. With these insights for the future development of the for the JavaScript engineers, we'll try go to the next. So that's all about my presentation today. Thank you, and looking forward for any questions. Thank you.